Implementing an SSD storage device in a desktop or notebook computer can significantly increase the overall performance of the system. However, the same flash memory technology that makes SSDs so much faster than standard hard disk drives also introduces other maintenance and troubleshooting issues that you need to be aware of as a PC technician. In this lesson, we'll review several of these issues and what you can do to keep SSD drives running properly. Most file systems used by PC operating systems, such as NTFS, do not store files contiguously on storage devices. Instead, to use storage space more effectively, the file system divides files up into chunks and stores them in free locations wherever they can be found on the drive. This process is called fragmentation. Fragmentation on SSD storage devices is less of an issue than on hard disk drives. File systems such as NTFS still fragment files when writing them to the drive to optimize storage space. But SSD storage devices don't have read-write heads. Therefore, no repositioning must occur to read a heavily fragmented file. The SSD drive doesn't care where the fragments are stored in its memory chips. A fragmented file can be read as quickly as a contiguous file. Therefore, when working with SSD drives, you don't actually need to defragment them, as you do standard hard disk drives. In fact, it's actually bad if you do defragment SSDs. This is because SSDs wear out over time. Each cell in a flash memory bank has a finite lifetime. It can only be written to and erased a certain number of times before it fails. Running defragmentation utilities cause many write-erase operations to occur. While this doesn't affect standard hard disk drives, it quickly uses up the flash memory's finite lifetime. Therefore, you should use Security and Maintenance and Control Panel to disable automatic disk defragmentation on Windows systems using SSD storage. In fact, this is one of the key maintenance issues you need to be aware of when using SSDs in a computer system. Some PC applications tend to overuse storage devices. For example, audio, graphic, and especially video editing applications commonly require a very large number of write-erase operations to do their work. As a result, they can cause SSD storage devices to fail prematurely. However, these applications also benefit greatly from the increased speed offered by SSD storage devices. Therefore, if you choose to use SSDs with these types of applications, you should consider configuring an automatic data backup process, such as backup and restore or file history, to regularly back up the data stored on the SSD drive on a traditional hard disk drive. In fact, many system implementers use a mix of storage devices in high-performance systems, so that heavily used information is stored on a standard hard disk drive. For example, the Windows operating system and its applications may be installed on a less expensive but more durable standard hard disk drive. Also, only data required for high performance is stored on SSD storage devices, and any important data on the SSD is automatically backed up on the standard hard disk drive. One way you can extend the life of an SSD is to enable trim functionality. Trim allows the operating system to communicate with an SSD and inform it which blocks of data on the device are no longer required and can be wiped clean. This prevents the SSD from storing unnecessary data and being overused. Windows should automatically detect that you are using an SSD and enable trim for you. You can verify that this is the case by opening a command window and entering fsutil behavior query disable delete notify. This command will return either a 0 or a 1. A value of 0 indicates that trim is enabled, but a value of 1 indicates that it's not. You can manually enable trim on an SSD drive by entering fsutil behavior set disable delete notify 0. In this lesson, we discussed issues you need to be aware of when maintaining SSD storage devices. We discussed fragmentation issues, SSD wear issues, and trim issues.